Hello, everyone. Welcome back. We're so happy you're joining us today. There have been so many wonderful sessions, and you're in for another great one. I'm Erin Gray, the Grants Manager with NumFocus, and I'm delighted to meet all of you. I'm learning so much from all of the sessions. So really excited to introduce Fastplotlib, and Kushal Kolar and Caitlin Lewis are our presenters on this session. Just a reminder that we love to have your engagement, questions, and comments in the chat. So please feel free to add those in the chat if you'd like. There's also a QA feature for you too. So if you have a question that you want to post, or even if you want to post that anonymously, feel free to. We're so glad to have you here, and I'm going to go ahead and turn it over to Kushal and Caitlin. Thanks so much.
Thank you, Erin. Hi, everyone. Thanks for coming to our talk. Today, we're going to be talking about Fastplotlib, which is an open source library for doing general purpose scientific visualization. And so we're going to show some cool examples and give you kind of an overview of the library and show you kind of the stuff we've been working on most recently. And so kind of to motivate why we even started this library, we want to talk about how important it is to look at your data. And so, kind of with this classical example, visually what we're seeing in these data sets is that they all look very, very different, but yet the summary statistics are all the same. And so, when you're working with a lot of different models and using statistics and trying to analyze your data, it's important to also be looking at your data and making sure that everything that you're analyzing and the outputs from these models, make sense. But with that being said, data visualization can be really hard. Rendering needs to be fast, and a lot of times you could be working with really high dimensional or large scale data, and that isn't easy to always visualize, and also to interactively visualize those things. So to be able to move around in your data and explore it a bit and make these large scale interactive visualizations, a lot of existing Python visualization libraries, it might be harder to do that, and a lot of it has to do with the technology, but then also maybe the APIs or the entry to the barrier to entry. There's an overhead in learning how these APIs work. And so, our goal with building this library was to develop something that is easy and friendly for users to get started with very quickly. And so we'll get into that in a few minutes of how we do that. And so also, kind of further motivation in general also is like, why don't scientific plots look as good as modern video games? And this is kind of on the side of how graphics technology has improved just so much over the last 20 years, from this video game on the left to this video game on the right. There's like a clear difference in, how can we use this newer technology also for scientific purposes as well. And so just to kind of give an overview of the entire stack that we are working with, we're going to start by just considering, we have this task where we have this RGB image that we want to plot. What would that look like? How many lines of code and how difficult it is as you go down the stack. And so at Fastplotlib, which is where we're going to spend most of our time focused today, this would take about 4 lines of code. So you would create a figure, you would have your data, you would add your data to the figure, and then you would show the figure. Very easy, simple. But then as you go down the stack, it gets more and more complicated. So Fastplotlib is built on pygfx, which is a rendering engine, which is in turn built on WGPU. And so basically, to do this simple task at this next level of abstraction down, it takes significantly more code, even to just do something so simple. And as your plots get more and more complex, this would become a bit infeasible. And what Fastplotlib really does for you is kind of abstract away this boilerplate rendering engine code that you don't necessarily need to focus on, to allow you to focus more on your data. And so, as your plots, like I said, get more and more complicated, it gets, this becomes a bit infeasible. And so you kind of need a layer of abstraction above that. And to go below this, more towards the GPU level, it becomes hundreds of lines of code to just plot a simple image, which is really intractable. But, just kind of to highlight what you can do with pygfx and kind of what it's built for more is more on the gaming engine side of things, and to have this fine-grained rendering control. And so this project is developed by some great people out of the Netherlands, Almar and Karine, and they've done a lot of work. But we're basically focused more on the high-level scientific side of things and how you can create these really powerful interactive visualizations. And then just a little bit more, like even below this, what is the hardware that's being leveraged to make these cool visualizations is these newer technologies, Vulkan, Metal, and DirectX 12. And basically what they allow you to do is leverage modern GPU hardware better than OpenGL, which is kind of like the old standard that's being phased out a little bit. And so this is what allows you to create these really performant visualizations that we're going to show in a few minutes. But, kind of just to bring it full circle, we're going to be spending all of our time for the rest of the talk talking about Fastplotlib, and just to give you kind of, some intuition to do this simple task. It would take about 4 lines of code, and, as you go further and further down the stack, it gets more complicated. And so that's kind of why we've built this library. And so Fastplotlib is a high-level API for scientific plotting. We've taken a lot of inspiration from pygfx and other libraries. We're built on top of the pygfx rendering engine. The project is relatively still new, only 3 years old, and the goal is fast visualization and fast user implementation. We want to allow our users to create these visualizations with minimal cognitive overhead. And so if you can think of your data like a NumPy arrays, then your ability to work with Fastplotlib is going to be really, really easy, and you're going to be able to do it very well. And so Kushal and myself are the core developers, and we also have some other major developers at other institutions and that we closely collaborate with, and have also been helping with the project. And so, what can I do with Fastplotlib? It's GPU accelerated visualization. And honestly, a modern integrated GPU is sufficient for many use cases. So you can do a lot of stuff, just with your local laptop. And create some cool stuff. And it's, geared towards doing rapid prototyping and algorithm design and creating these really large scale interactive visualization. And so we're going to show some examples in a few minutes. It's also great for if you're working with ML models and kind of designing and developing how to evaluate them and do quality control and kind of see your model output and synchronize that with the data and make sure that everything is making sense. And fast rendering and exploration of these large scale data sets, and also for doing real-time acquisition and work with streaming data, either for example from a microscope or working with neural data, streaming data straight from the brain. And so where can you use Fastplotlib? So the great thing is that, you've read it once, you can run it anywhere. And so it's identical code, whether you're working in JupyterLab or, using Qt or GLFW. And what makes this possible is Render Canvas, which is a library also developed by the same people doing pygfx. And this is great because it means that, you have this really large scale data and it can live on the cloud or a remote infrastructure. And then you're able to, do some type of prototyping and then ship it either as a full app but basically have your data live somewhere else. You don't necessarily have to have it locally and still be able to have these visualizations. And so kind of just a brief overview of the API. So basically you have a figure, and that figure can have, a single subplot or multiple subplots, and you basically add graphics to your subplot. So that could be something like an image, which is what I've shown you before, or you could also have an image volume, a line, scatter, some type of surface, vectors, all sorts of different things that you might want to visualize, and also some different selector tools. And you basically are able to then define interactivity between these graphics, between subplots, that allows you to build up kind of these complex visualizations that we're going to show you in a minute. And then, also we have been working really hard recently on an ND array widget, which basically would allow you to pass in multiple n-dimensional arrays and then automatically generate graphics and sliders to view different slices of the data and kind of see your multi-dimensional data very easily. And so this is great, especially if you have, large scale data that's at different sampling rates. This will handle that for you automatically, and you can kind of synchronize things nicely. And so now I'm going to turn it over to Kushal, and he's going to walk through some examples showing you some more recent stuff that we've done and kind of, how expressive the library can be.
All right, so Caitlin just gave you an overview of the library, and I'm going to walk you through a couple of examples. They're going to be mostly neuroscience focused since that's what both of us mostly work on, but Fastplotlib is intended to be a general purpose scientific and engineering library that's applicable to many different disciplines. So let's start with something simple. So Point tracking is something that a lot of people do. A bunch of models have been developed for this over the past decade. And what Fastplotlib lets you do, it lets you very easily, like, visualize a video and visualize other data that's associated to it. So like in this example, we're showing you points that show you the point tracking results from every frame, and also a trajectory of how those points are evolving over time. And kind of a nice thing is that in Fastplotlib, you very easily use colors to represent different physical features, like in this case, like velocity or acceleration, along these lines. So the key takeaway is that Fastplotlib makes it very easy to create interactive visualizations like this. So here's another example that's a bit more involved. So what we're looking at here is actually some of the data that Caitlin works with, where data is being streamed live from the brain. And what you're seeing on the left is basically several hundred different time series. And what each line represents is voltage that was recorded from the brain. And you can see, some of these like yellow dips, which are thresholded activity. And then on the right, you can see some process data. And the key takeaway from this is that this data is being streamed in a very high rate, 30 kilohertz or 30,000 hertz, and it's being processed and then displayed very quickly with a latency of 5 milliseconds. And Fastplotlib is something that allows you to do this. Look at live, real-time data that's streaming in and view it with very low latency. So Fastplotlib is not just for building visualizations, but you can actually also use it to build entire applications. And this is something that like one of our collaborators is working on. So you can have mGUI UIs that are embedded directly within the same canvas as a Fastplotlib figure. And you can basically use these UI elements and events, and create a fully fledged application that you can ship to end users. And a nice thing is that since Fastplotlib works the same whether it's in a notebook or whether it's in Qt or GLFW, what you can do is you can prototype and develop like your algorithms or models in a notebook along with Fastplotlib, and then also actually even develop your application in the notebook if you want. And then that same code will pretty much work in a Qt app as well. So it really reduces the like this overhead of going from having a model that works in your notebook in a prototype situation to building a fully fledged application from your models. So here's another example of model exploration, like a real example of model exploration. So this is showing an example of a QLVM model, which is similar to an autoencoder, but unlike an autoencoder where you typically have to go down to about 32 dimensions in your latent space before things start to break down, a QLVM that's being developed by some of my collaborators allows you to go from your high dimensional data representation down to just a two-dimensional latent representation directly. And as you can see here in this example, with like a QLVM model that was trained on the MNIST dataset, this latent representation is actually very interpretable. And what we're showing here is that you're using Fastplotlib to move through this latent space and interpret what each point in your latent space represents. So I'm going to show you an example of how we can use that QLVM model on some actual real data, not just a toy data set. But before that, I'd like to introduce you to these animals called Mongolian gerbils. They live in burrows and in families in Mongolia, and they're kind of similar to prairie dogs. They have vocalizations that they use to communicate with other members of their family. Like for instance, if they see a predator, they may have like a specific vocalization for the predator, or if there's something else that they see in their environment, they may have a specific vocalization for different things in their environment. And I'm collaborating with these researchers that are basically making these large simulated burrow environments and at the same time they're recording video to see, you know, what these animals are doing, how they behave, and they're also recording audio at the same time. That's what you see on top here. And you know, this is just a simple visualization example of how you can use Fastplotlib to, you know, explore your data, like explore your behavior video data in conjunction with your audio data very easily. And then what these researchers are using is that they're taking each of these vocalization snippets of like when some interesting vocalization is occurring, and they are passing it through a QLVM model. So that's what you're seeing here. And then what you can get is a latent representation of your vocalizations. And you know what Fastplotlib lets you do is you can very easily, you know, explore this latent representation and try and get an understanding of, you know, what does your latent represent in terms of the real data that was used here. And this is something that we don't have yet, but we will have very soon, is, you know, being able to combine, you know, this latent representation that you're showing here with the like live streaming behavior video and live streaming spectrogram data, like what I showed you on the previous slide, so that you can, you know, you can look at what is the animal doing and what are the vocalizations at that time point and map it to your latent representation simultaneously. So, you know, this is the kind of takeaway from this is that, you know, Fastplotlib lets you take real data sets, explore those real data sets. But, you know, in addition to that, what you can also do is you can pass those data sets through models, and you can sync everything together to get a really good understanding of how your models and your real data sets interact. And here's another example of something similar. So what we're seeing here is a mouse that has been trained to perform a task. So, you know, this is a mouse over here. And what it's doing is it has to extend its arm out and reach a food pellet over here. And then what you're seeing on the bottom left here is neural activity, similar to what I showed you a few slides before. From like a probe that's in the brain and recording the activity of a bunch of neurons. And then on the bottom right here, you're looking at a latent representation of that neural activity. And, you know, what this visualization allows you to do is, you know, you can look at how's the mouse behaving, and then you can look at your neural activity. And, you know, you can also simultaneously look at your latent representation of the neural activity, you know, all in sync. And, you know, so, you know, the key thing is that Fastplotlib makes it very easy to create these visualizations that let you, you know, combine, you know, real raw data with models that you're using to try and interpret the data. And here's a much more complex example of model exploration. So you can also use Fastplotlib to, you know, develop large human-in-the-loop ML systems for, you know, not just exploring models, but also changing model parameters, and then, you know, assuming your, you know, your model inference is fast enough, you can immediately visualize the results of those models. So what we're showing here is, you know, on the top left is like raw, noisy neural imaging data. And then in the top middle, we're looking at that data after it's been passed through a denoising model. And you can, you know, you can clearly see that, you know, this denoising model performs pretty well to denoise this raw data. And, you know, some of the key takeaways here is that, you know, Fastplotlib lets you visualize these very large data sets, which can be, you know, hundreds of gigabytes large, and render them very quickly. But you can also develop, you know, human-in-the-loop ML systems where, you know, you have like a mini application here where you are changing the parameters of your model, and then you're immediately viewing and exploring the results of that model. So, you know, in this case, you know, you can very easily, you know, change the parameters of this denoising model, and, you know, you can immediately view and get an understanding of, oh, is this denoising model performing well, by, you know, clicking around some points and seeing what those results look like. And performing, like model evaluation and quality control like this can be, very challenging with just static visualization. So having, fast interactive visualization systems is very critical for something like this. And here's a more complex example. So what we're seeing here on the left is neural imaging data, similar to what I showed you on the previous slide. But a model is also being used to actually like segment out individual neurons in this, and then look at their activity over time, over like the course of the entire recording. And then in conjunction to the neural activity, what is also being displayed here is the behavior of what the animal is performing at the same time that the neural activity was recorded. And then on the bottom right here, we're showing you, some of the like physical or geometric features of the behavior. Like what we're seeing in the red over here is the pupil diameter of the mouse. And having large visualizations like this is very useful for changing model parameters and then immediately looking at the results, but also performing quality control. So what we are, what this is really useful for is, for example, in this visualization of the pupil diameter, a lot of these spiky things are actually not real changes in pupil diameter. And this visualization, kind of lets you see that, this point tracking model is actually not performing very well because, these points are moving around anytime the spikes. And, getting a feel of your model's quality can be difficult without having fast interactive visualizations like this. Okay, so that was an overview of a couple of examples of how Fastplotlib is useful for a variety of use cases. They were very neuroscience focused, but a lot of these same concepts are applicable to many scientific disciplines and domains. And yeah, I'll hand it back to Caitlin for the rest of the talk.
Yeah, so Kushal showed you a bunch of cool examples of like some data sets that we both work with in our PhDs, and they are primarily neuroscience focused. But really, like he said, we're just trying to get across to you that creating these interactive visualizations and kind of synchronizing your data that's multidimensional or very large can be very easy, and like how you can kind of then see model output and your raw data. And for us, we're trying to, answer scientific questions at the end of the day. But, if you're, interested in getting started with the library, we also have this really nice examples gallery. Hold on, I think it's okay. And with this examples gallery, sorry, I clicked on it, but I don't think I'm sharing my screen properly for you all to see it. But this image on the right should do fine. But we have over 100 plus examples, and we would love to add more examples for your use case. But all of like the individual simple components that kind of can be used and orchestrated to build these more complex visualizations, this is a great way to get started. And just kind of to briefly touch on some future directions that we would like to take this project, and some other avenues that would help in terms of making the visualizations more performant, or some other areas of interest, making like a WGSL JPEG encoder to make the remote rendering faster. So that's going to make the performance better. And then also combining these visualizations directly with computations that you might be doing on the GPU. So potentially integration with something like TinyGrad or some PyTorch like API that then you, as your model is training, for example, you would be able to kind of visualize what's going on. And that could also be helpful in terms of like is my model doing well even in the training phases. So those are just some cool things that we've been thinking about. But in all, we would like to help you visualize your data, and that's what we really love to do. And so feel free to reach out to us on our GitHub repo or by email. And then obviously Kushal, if you're based in New York or in the US, he runs a scientific visualization group that meets every 6 weeks. But because this is global, do feel free to reach out to us via email or on GitHub. We would love to hear from users and to continue to grow and develop the library. And we just want to say thank you. Sorry, we were around this afternoon, evening. We just gave a talk at PyData Boston, so that was for that. But in general, thank you for coming to our talk, and thank you. We want to say thank you to the institutions, that we collaborate with and that have been a part of the project, and that we are, open to collaborations in academia or industry in general to, continue to develop this project as well. So thank you so much, and we'll take any questions now.
Thank you, guys. We do have one question in the chat. Can you hear me okay?
Yes. What does QLU show stands for? Is it possible to more dimension of the latent space, maybe with a video with Fastplotlib?
Yeah, so some people, my collaborators are also looking at like latents that are three-dimensional. You can just set, I think, the parameter for what, how many dimensions you want. What does it stand for? The Q stands for quasi. I think the L stands for latent. One sec, let me see. What does it stand? Yeah, quasi. Oh, sorry, it's quasi Monte Carlo methods. Yeah, it's quasi Monte Carlo latent variable model. Yeah.
Hopefully that answers your question. Any others?
Yeah, anyone else have any more questions? We have just a few minutes left. We'll give you just another minute here to enter any questions you have, and then we'll wrap up. And everyone, if you do have other questions that come up later, you can always go into the Discord and ask over there in the proper chat line there. We got another one from Albert. I'll put that up here on the stage.
What are the fundamental principle behind this visualization? Sorry, could you elaborate a bit on? I'm not sure I understand what you mean.
Based on the types of modeling.
I guess maybe as I understand your question, so in a lot of the models, it's like if you're talking about perhaps the types of graphics needed, I mean, it's lots of imaging data. So you're displaying movies, and then also, if you are like have segmented neurons, you would have like contours on top of those movies, and then also like lines to show the activity over time or scatters. Hopefully that answers your questions. So for example, in the QLVM model, like the latent space that is being showed is as a heat map. And so then there's, interactivity based on different samples that you have in this latent space and how they connect to the larger data that they're working with.
All right. That looks like we have it about wrapped up. We are at 10:28, so we will go ahead and end the session here. Again, if you have any more questions for these folks, you can head over to Discord or go into the lounge possibly or message. So thanks so much. Really appreciate it. And we will see you at the next session.
Thank you.
Thank you.